So I really enjoy playing with microcontrollers, especially ESP31, 32, and Arduinos. And so I will show you today how I built a little security camera with AI and an ESP32. So I built the security camera. Well, security, we are in Portugal, so we can all, so it should be able to detect things. So one of the objectives for this was to be able to detect what's in the picture without having to actually look at it. So for this, I will be using the Workers AI API to more or less simulate like a real-time detection. It's just not real-time. I will explain more further. And so basic summary all I'll be showing. An ESP32 will take a picture every 5 seconds. It sends the picture to a worker. The worker will process the data object detection and store everything and show you a small UI to see this in real time. So what is an ESP32? Has anyone ever an experience playing with Arduinos? Anyone tried one before? Okay, a few people. So an ESP32 is similar to what an Arduino is, meaning that you'll have a lot of pins that you can either use to input electricity or output electricity with a little more specific. So the ESP32, the big difference to an Arduino is that it has Wi-Fi and Bluetooth. So it can connect to everything and you can build way more advanced applications. Not only the Wi-Fi and the Bluetooth, but also the CPU is also much more powerful than an Arduino one. So this is just an example of the pinouts, so you can see. So the way a microcontroller works is basically on two functions. So the first one, the setup, you can execute things that are run only when the ESP is turning on. And then the loop is called every time, multiple times a second to run repeated tasks. So for example, in the setup, you might want to define a specific pin as an output so that you can later on execute actions based on your controller. So just getting started, you might want to install Arduino. For this example, I'm showing you that you need to use version 2, the latest one. Then you need to add the ESP32 repository and install the boards. So this will give you all of the Arduino compatible software for you to be able to program your microcontroller with the same language as Arduino. And then just paste the code. So I have to be honest because I didn't write the code for what I will be showing you today. Most of the code is from this website, randomnerdtutorials.com. And I will explain a little bit of how it works. So essentially what you are seeing now on the side is the definition of the imports, what your Wi-Fi is, password and SSID, and the host name for where the pictures will be sent. And then we come back to the setup function that I set up now, that I referred previously. So in this, we are showing a bunch of logs with serial prints, seeing that the device is being connected to the Wi-Fi and being able to reach the server. And then it configures the camera definitions. So for a microcontroller to be able to take a picture, it needs a lot of definitions. And you are seeing this now. I don't know what this does, but I know it works. And then this is very similar to C. So you might be familiar with it already. So here is a simple function that just takes the picture. It turns on the LED high. You can see it's the second line. So it turns on the LED, takes a picture, turns off the LED, and then just does a basic HTTP post sending the image to the remote server. And then the loop is just calling this function every few milliseconds. And then you are off to go. So now you need to connect your ESP into the computer. Here's a little photo, and then you flash it. This is a very high-level introduction to how to flash a microcontroller. I can't go into more details here in this little presentation. So it should work. So now if you connect it, it should connect to Wi-Fi, take the pictures, and try to post. Now, into the server side, that is what I think is more interesting. So here, I'm building with a Cloudflare worker. This might be too much information on the screen. I regret it now. But it needs to do two things. So it needs to handle the upload of a new picture, and then it needs to handle listing this picture, the pictures that have been taken for you to be able to see what's on the screen, and also do the object detection, of course. So going over the upload function, what it does is just receives a function. It calls Workers AI. So Workers AI is the AI platform from Cloudflare. It's really easy to use inside the worker. So it takes a picture and sends to this model, the ResNet 50 from Facebook. And it already detects all the pictures and returns a list of objects detected on a picture. But it is just a model. So not all objects the model says are on the picture are really on the picture. So on the second step, I'm filtering out all of the objects that have a matching score less than 90%. And then after that, just storing the picture and the detected objects on a bucket for later use. And then listing objects is very similar. So it just goes into the bucket, it takes the latest uploaded objects, aggregates into a JSON, and returns everything to the client to see. So now, how does it works in really within the UI? What should we see? So we need to see the pictures, of course, and then we need to see the objects. So building an object detection can be difficult because now you need to overlay on top of the pictures that have been taken boxes with the objects detected, as you can see on the side. The red boxes can be difficult to generate on top of and layer on top of the previous images. So this is where ChatGPT comes into play. So I just ask him, okay, I have this list of pictures and this list of objects with the coordinates. Can you generate something that looks something good? And what you're seeing on the image is just like the first output from the model. And it worked, not first try, but with very small changes, it just worked. And now it's demo time. Okay, so I built this at home, and not sure if shaking it will help. Okay. So it's flashing, meaning something is getting uploaded. So if I go now into the web page for a worker, it's showing. It's not really real time. It's semi-real time because the ESP is only taking pictures 5 minutes, 5 seconds at a time. Sorry? Yeah, it takes a little time. So maybe it's too much stuff on the screen. I mean, it's detecting persons, so or two TVs, so it's fine. Bench, chair, person, TV. Most of the time, almost everything is well detected. And so this is just showing some stuff some fun that you can have at home. So from here, what you can do is that all of this is JSON, so you can easily parse what's showing on the image. You can detect if a person is showing on an image, you can send an email, or you can send a notification via Telegram, or send something for you to be able to take action. Maybe you have a dog at your home and you see, oh, I don't want the dog to go into this place. So you can detect if the dog went there and call you. So this is a typical Cloudflare worker. It's just a Wrangler. In this case, the Wrangler is just as the AI binding. So it allows me to execute AI inference, and the R2 bucket that allows me to store the image and then fetch later. And then this is really small. So 95 lines does this. So I have two paths. The upload one is for handling the upload images from the ESP. I just take an image, transform it into a array buffer, and send the image into the model that I said previously, so the ResNet 50 from Facebook. And then filtering out the objects that probably aren't well detected, and storing everything into an R2 bucket. And then the listing the files is mostly the same. So it just goes into the bucket, it lists the files, those reverse the list because the files are orderly by time, and you want to get the latest ones first, and then just returns the images. And then I have this web page, the one that was generated by ChatGPT. It just calls this endpoint, the list one, and does a bunch of things with HTML canvas to generate the overlay, and just calls this every 5 seconds as well. I said that only the HTML page was generated, but actually the worker code was too as well. So this is just to show that models can do a lot more today than it did a year ago. So generating a simple worker code can be done with a little prompt, and it will probably work fine at first try. And that's it from this demo. So it's just I've been also impressed by the capabilities of the models. So I just wanted to share it with you.